Welcome guys to Let's Lock In Baby. And today we're going just look at this for some seconds. Wait. Yes. We in previous video we learned about molar volume. This remember Avogadro's law. Okay, for this one, volumes are same temperature and pressure substituted by molecules. Now Weber density is basically a ratio between the mass of a given volume of the gas or vapor with respect to the same volume of hydrogen under the same conditions. Blah blah blah. This is the definition. This is the formula. Now we are going to learn about how we get the formula. Actually, this one. See, mass of one molecule of the gas or vapor divided by mass of one molecule of hydrogen, but hydrogen is diatomic, so we can write 2 atoms here, multiplying by 2 on both sides. So this cuts 2 into this, and this is relative molecular mass or molecular weight. We can write it as m, and mass of one atom of hydrogen is nearly 1.008, which we can approximately take it as 1. So we can get m equals to 2 into Vd. Now there is some doubts of why we take hydrogen. This is the reason. Okay, this is the reason. Take a screenshot of it. Now as we have already got an idea of what is vapor density, right, that it's the ratio between the mass of a given volume of a gas divided by the same mass of the same volume of the hydrogen gas. Now yesterday we were doing a numerical. Okay, yeah, we were doing a numerical. Yes, which was the vapor density of a, let me write it. So we got this question, as you can see, that the Vd of a gas is 8. This came in 2013 ICSC. The vapor density of a gas is 8. What would be the volume occupied by 24 gram of the gas at STP? Now it's basically simple. We need to find the number of moles, right? Yeah, we need to find the number of moles. Now, yes, we know Vd of a gas is equal to molar mass of the gas or molecular weight of the gas divided by 2. From the relation this, writing it directly, just write this and then do this, then box it so that teachers can see what you're writing. Now molar mass, we don't need it actually, we just need to write this. Sorry, we need to write this on. We need to find the molar mass, not vapor density. Vapor density is given. Sorry, mistakes can happen. Now we need to find molar mass. The molar mass, m equals to 2 times Vd. So this is 2 into 8 equals to 16 gram per mole. Now we know number of moles is equal to mass of the substance divided by molar mass. Mass is given 24. This is 16. So 6, 4, 3, 2, 1.5 mole. Now this is at STP, so it's easy. Now 1 mole of gas at STP occupies 22.4 liters. So 1.5 mole of gas SUV occupies 1.5 times 22.4 liters. Now we need to do the calculation. This is simple. So 50 into 224 over 100. Now the calculation, and if we do the calculation, we can actually do the calculation. Wait, let me take another notebook. Let me do it. So it's coming. Let me check the, yeah, it's 3360 divided by 100 liters. Okay, do the calculation. It gives 3360. So just do this, cut this, you can get 36.6 liters. So then write this statement. So the volume of the gas at STP will be 33.6 liters. Okay, these are the type of question you mainly get in ICC, and this came in ICC 2013. Okay, give a screenshot taken. Good. Now we will do some vapor density too. So we can take this book, not sponsored by the way. Now you've learned this vapor density. Now we find vapor density. Take a screenshot of this, do these, and CPs. These are the type of numericals you're going to find in Selena. Let's do one example. Okay, let me teach you how to do the example numerical. So wait. Yes, now let's do the numerical. I'm not writing the question now, just doing the sum, just keeping the, yes, going to do the solution for the example number 17 of Selena Concise. Okay, class 10. Now what is given? Actually, this is a tricky question. A gas at a pressure of this, temperature this, occupies this at STP. No, sorry, this. If at STP it occupies 1.5 gram, find the vapor density molecular mass of the gas. 1 liter of H2 at STP with this. Now you need to have the idea of gas law, which is basically combined gas equation. P1 V1 by T1 equals to P2 V2 by T2. If you don't have this idea, you can't basically do this. You need the idea of this, because this comes from both Boyle's law and Charles' law, and sometimes you can basically use the Avogadro's law, but it's no use here. Just use these to get this equation. Now using this, P1 is basically 700, B1 is 702, T1 you have to change it into Kelvin, write the units. Okay, write the units. Dated by x milliliter, and T2 is 273 Kelvin. Now P1 V1 by T1 equals to P2 V2 by T2. 700 into 700 divided by 330, 760 into x divided by 273, cuts 1191, cuts, we get x equals to 700 into 7 into 91 divided by into 76. Okay, we get this. Now this is a little bit of a big calculation, so wait, just don't write milliliter here. Yeah, bit of a big calculation, so I'm going to show it right now. Wait. Okay, so I did the calculation. This is coming 533.37 milliliters. Okay, now given that 533.37 milliliters of the gas at STP weights 1.5 gram. Now we need to take 1000 milliliters, or the same volume of the hydrogen basically, of the gas at STP is 1.5 divided by 533.37 into 1000. Okay, which gives this much mass. Now wait, and now vapor density will be weight of 1000 milliliter of the gas at STP divided by weight of 1000 milliliter of H2 at STP. Now we have given the weight of H2 at STP, so let's put the values that we got, and we get this. Now molecular mass is just 2 times of VD. Now this is 2 into 3, 1.25, 10, 4, 5. Okay, so we got 0.5, and this is 62 gram per mole. So we can write, or we can write it as 62.5 grams. So molecular weight, so we can write vapor density is 31.25, and relative molecular mass or molar mass is 62.5 grams. Okay, this is the answer. Take a screenshot. This is the use of combined gas law. Thank you for watching. Tomorrow we will this part will be completed right now. Okay, and tomorrow we are going to learn about empirical formula, and just take a picture of these as per notes already have taken. Okay, so basically tomorrow we are going to learn about these. Okay, oh yeah, just remember how to calculate percentage composition, that is mass of that quantity in compound divided by mass of the compound into 100. It's basically total mass divided by, say, we're going to find the mass of percentage of hydrogen in sulfuric acid. So it is 2 by 98 into 100. right? Because mass of H2SO4 is 1 molar mass of H2SO4 is 98, and 2 by 98 is just what, 949, and 100 divided by 49. I want to for now use the calculator, and if we check it right now, I'm using the calculator. 100 divided by 49 is 2.04. I can write. For now I've used the calculator. Don't use the calculator, please, I beg. Like, for now, for learning purposes, I use the calculator. If you do this calculation by manually, you will get the, you will get this. So thank you for watching, guys. Hope you like the video. Tell me what do you want to learn next video, because I am actually my 10 is starting, and maybe the videos may become bit late, or yeah. So right now this is the video, and I think next day I will actually for now stop this chemistry, or try to continue this series, but I'm actually going to teach you guys little bit of talk, the force chapter, the first chapter, that is force of class 10, and do some numericals just to understand the basic concept to my perspective. Basically it would be very hard, and yeah, this for now. Take a printout of the ICSE science chemistry. This for the class 9. For class 10 you have this class 10. For more chapter you see the syllabus. For other chapters, I'm going to also start with the study of acid base salt, the pH part, which is basically the numerical part right now, because others are just like, I can't say, in Hindi it's like tukka maro. Okay, so wait, let me just write this. Yeah, pH is used this, but later we are going to learn it. Right now we are learning about vapor density, molecular mass, number of moles. Later I will start Gay-Lussac's law, and in terms, and a little bit of the ideal gas law, which I was talking about in previous parts of this series. So thank you guys for watching. Hope you like the video. Like, comment, subscribe, and support me.